This lecture is an introduction to alkanes. Alkanes are aliphatic hydrocarbons with only carbon-carbon and carbon-hydrogen sigma bonds. Alkanes can be classified as acyclic or cyclic, and acyclic alkanes are considered saturated. That is, they have the maximum number of hydrogens possible. They have a molecular formula of CnH2n plus 2, and common examples are methane, butane. 3-methylpentane is an example of a branched alkane, so it's branched at this point. Petroleum is a mixture of alkanes with 4 carbons or higher. For cycloalkanes, they have a molecular formula of CnH2n. If you calculate the degrees of unsaturation, cycloalkanes will have 1 degree of unsaturation for every ring. Examples are cyclobutane, 1-methylcyclopentane, and cyclohexane. Alkanes consist of sp3 hybridized carbons. Recall that these are tetrahedral in geometry. If you look at the 3D model of ethane, you can see that this is the carbon, and this is the hydrogen that's in the plane. This hydrogen is coming out of the page, and we depict that using a wedged bond, and this hydrogen is going towards the back, and we depict that using a hash bond. We can classify carbons according to their substitution, and we call this the degree of substitution. A primary carbon is attached directly to one other carbon, and we abbreviate this as 1 with a degree symbol. So this is an example of a primary carbon because it is attached to one other carbon. In ethane, both of these are primary carbons because they're each attached to one other carbon. In butane, the terminal carbons are primary carbons because they are attached to one other carbon. The internal carbons are attached to 2 carbons, so they don't qualify as primary carbons. In this last example, we have this as a primary carbon because it's attached to one other carbon. And then if we consider the carbons in this ring here, these are each attached to 2 other carbons, so they don't qualify. But these 2 carbons are also primary carbons. They're attached to only one other carbon. Secondary carbons are attached directly to 2 other carbons, and that's abbreviated as 2 with a degree symbol. So this is what a secondary carbon would look like. And if we go back to butane, this is a secondary carbon. This is a secondary carbon. Remember that these were both primary carbons. If we look at this example, these carbons are attached to 2 other carbons. So this is secondary, secondary, and secondary. And remember that this was primary, as was this and that. A tertiary carbon is attached directly to 3 carbons. So this would be the tertiary carbon. And in these 2 examples, if we look at this example here, we can see that this is a primary, so all these terminals are primary carbons attached to one other carbon. This is a secondary carbon, and this is a tertiary carbon because it's attached to 3 other carbons, 1, 2, and 3. In this example here, we've got primary carbons here. And then if we go around the ring, this is attached to 4 carbons, so we'll come to that. This is attached to 2 other carbons, so it's secondary, as is this one and this one. This one is attached to 3 carbons, so it is tertiary. Quaternary carbons are attached directly to 4 carbons, so this is a quaternary carbon. If we go back to the same 2 examples, in this case, this is a quaternary carbon. It's attached to 4 other carbons. This is also a quaternary carbon. It's attached to 4 other carbons. Hydrogens are classified according to the carbon classification. So if a hydrogen is on a primary carbon, that hydrogen is considered to be primary. So for instance, in this case, this is ACH3. this is a primary carbon. It's attached to one other carbon, and all of these hydrogens are also considered primary. So all of these hydrogens are also considered primary hydrogens. Likewise, if we look at this carbon, it's a secondary carbon because it's attached to two other carbons, and these hydrogens are therefore also considered secondary. And finally, this carbon, it's a tertiary carbon, and so this hydrogen is also considered tertiary.